Hello, and thank you guys for coming to this presentation. My name is Shane Spencer. I'm with Microcom based out of Anchorage, Alaska. With me today is my coworker Josh. He's sitting right over here, and if you guys have any questions about Microcom, anything that we do, he can help you out as well. This is my second presentation at Astricon this year. I had a talk yesterday on Dundee and noticed a few people had extra questions, so please let me have your business cards or write on one of mine if you don't have one. I'd like to follow up with you, make sure that I stay in contact after the conference. I'll also be out in the hall as well, just shaking hands, saying hi. Love to talk to you guys about the stuff that we do. I'm pretty sure I was given 2 presentation slots due to some sort of snafu at Digium HQ. I submitted 3 talks, actually. One of them that didn't get selected was on crazy stuff you can do with CDR and CEL and how we made a search engine that really works with that. I'm very happy, however, that they didn't give me 3. That's a lot. And I'm pleasantly surprised that they gave me 2, so we're going to make the most of it. This presentation is about Amity. It's a homebrew project that we use. It's not really in use by anyone else, but it's just kind of out there saying, hey, you know, make your own tools, be a good tool maker, get stuff done, do your own security, all sorts of fun stuff. Be responsible for yourself if you need to, just to get the work done. This is just our way of integrating Python with Asterisk and is open sourced and available out there on GitHub. Also, I don't have a cool, oh yeah, I do have a cool laser pointer. All right, this is gonna be a little helpful. I also have a cat, which is better than a laser pointer in my opinion. So I'll just use the laser pointer. He's kind of slow. The laser pointer's like, it's always faster than the cat, right? So first off, what is all this? AMI, HTTP. It's the Asterisk management or manager interface over HTTP. It's just a nice, friendly way of putting a HTTP server on top of what some of you might already know of as the Asterisk manager interface, also known as AGAM. If that's not 100% correct, please tell me, Digium people, but it seems to be very much the same. And then Amity is our Python tornado Asterisk manager event, or interface event dispatcher. And I'm sorry for that title. Yeah, I'm still here. So how many of you guys use AMI from, like, say, PHP? All right. How many from Perl? Cool. How many from C? All right, yeah. Oh, okay, got one guy. And then how many from Python? 1. All right, I'm going to try to make that number go up a few. There's actually quite a few actively developed Python AMI projects out there, but like I said, we just made our own because we liked it. So the reason we chose to make our own adapter was for primarily familiarity reasons. We use Tornado in several of our other projects and kind of like the way it feels and really, really appreciate how it handles sockets. I also use it for a lot of my personal projects as well. Anybody here actually familiar with the Python Tornado framework? Awesome. If you're not, check it out. It's developed by FriendFeed, which is now owned by Facebook, to be a non-blocking Python-based framework for serving out web requests. It also provides non-blocking socket support, so that allows you to mix in a lot of protocols into one running project without a whole bunch of slowdowns. For example, you have HTTP servers and clients, SMTP, XMPP, tons of database connectors that are out there, mostly through the community, and most of them are on GitHub as well. Just got to search around a little. Microcom had some goals in mind when we started working with AMI. First, we wanted to interact with a lot of Asterisk servers, so we needed a project that could communicate with more than one at a time. So scalability is always something that we're interested in, and distribution of servers. The biggest thing is we wanted to receive call events, of course. We wanted to be able to monitor, for instance, RTP statistics all throughout our system, just so that we could kind of monitor how things are flowing. That's actually a heck of a lot of data. I don't know if you guys have ever turned RTP event logging on in AMI, but holy cow. It's very useful information as well. And we also wanted to handle that for a very high call volume, either on one server or on a ton of servers. Monitoring RTP statistics for hundreds of channels is something we definitely wanted in our scope. Reliable and timely event processing. I'm going to touch on that a little bit about how AJAM helps out with that. And then we wanted it to be accessible from our common environments, other Python-based projects, either something we can just mix in, whatever. And like I said before, allow for multiple protocols to all interact with each other from the same project. So HTTP, AMI, and AJAM sockets, as well as XMPP if we needed it. Definitely wanted to replace the system dial plan function, as well as a few other blocking functions. It really has absolutely no place in a high call load, so needed to get rid of that. Another key point, we wanted to use this project to help us notice what could be a potential security problem in real time without really relying on logging systems. Sometimes a lot of things happen, never hit the logs, never hit the CDRs, so we wanted to kind of keep tabs on everything. And we wanted a very cheap way of throwing that CDR information, since you can actually use the CDR manager interface into non-supported databases like MongoDB, and throw certain events into key stores like Redis. All right, so the Asterisk Manager interface, here's just a few quick examples of what you can do with it. If you're not horribly familiar with it, you can originate calls, you can watch for calls and channel call events, or channel events. You can manage conference calls, adding people, removing people, publishing something to a web page somewhere, stuff like that. And you can get server and configure information right off the bat, as well as modify the dial plan and do some real-time event debugging. Depends on what you want to send out events for. So hypertext transport protocol, we all know what this is used for. If you don't know what this is used for, I'm sorry, but the obvious answer, of course, is Facebook. We actually all use it, mostly for Facebook. I actually use HTTPS. I don't want to get hacked, but still. So the asynchronous JavaScript Asterisk Manager, AJAM, has been available since Asterisk 1.4. Is HTTP based and can be used, well, it can be routed and proxied. And it can use existing HTTP load balancers to distribute AJAM requests to a lot of Asterisk servers. How many of you guys distribute HTTP to a bunch of servers using like Nginx or Lydie or even Apache? Okie dokie. So a quick point on what asynchronous means at kind of a very high level. It's often referred to as event-driven programming. So you're requesting things, waiting for the universe to send you back something, all the while doing something else. So your program makes a request, handles a few other things while it's at it, and then sits around waiting for a response. It's also kind of said as non-blocking. So AJAM. This also gives us direct access to the AMI commands using very simple HTTP clients if we choose to use them. Things like wget or curl. Say you're a huge SMTP event person. You like to do stuff when emails come in. Maybe you want to get a call or something like that. You could totally use a filter once an email comes in to spawn up wget and actually do a call or something like that too. I don't know why you would, but this is what you can do. You can use bash if you want to. That's kind of a fun little use for it. Asynchronous event queuing, rather than requiring constant socket polling when you're just using AMI by itself. I kind of touch in on that on the next slide. Digium added the wait event AMI request, which was genius. I really appreciate it. And queues, not call queues, but queues of events, when using wait event and AJAM, are per authenticated session using session cookies, and those are utilized by the HTTP client to continue making requests without having to send authentication information, as well as it helps with that queue. Both AMI raw and XML encoded requests and response formats are available. So if you're more comfy in XML land, go ahead and use it. Asynchronous event queuing for AJAM clients. So this slide is kind of a side-by-side comparison of how events are sent to client sockets for both AMI and AJAM clients. So they're kind of doing this all at the same time here, starting at event 1. They both start at the same time. Event 1s through 2, through 3, through 4 all made it to both sockets. Both clients, due to a networking problem, disconnected after the 4th event and should reconnect as soon as possible, like a good client really should. Here, the AMI socket reconnects a few events later and then continues receiving events. Operation normal, right? They have no idea that they missed out on those other events. There's no backlog. Now the AJAM reconnects and uses the same session cookie that it was using before, and the few events that it missed actually get delivered to the AJAM client, which is just beautiful. You don't miss events. They are queued on the server for you, and they expire after a time. But this is where the reliability comes in into what we needed. So let's just real quick create an AJAM request, or an AJAM login request. So what we're going to be using is just the imaginary web server in your brain to go ahead and just make a call to a local Asterisk server. We're using the raw management protocol, and the action that we're sending out is login. You guys are probably familiar with this. If you guys use AJAM, I just want to point this out. Username and then the secret right there. What we get out of that is this super important session cookie, which we're going to continue to use on all subsequent requests. Keep that queue nice and happy. So we're going to go ahead and use that cookie. So whatever client that we're using, we went ahead and added that session to the cookie jar. And we can go ahead and issue a command. In this case, we're going to do an actual command and then core show uptime. So this is just like you're doing something from the CLI, basically. And we're going to get that back in raw format. Response follows. Here's the command that was run. Here's your system uptime. Yeah, it's 30 minutes or something like that. I actually issued a bug with Digium on this server, so no big deal. Where does this knowledge of how to use AJAM really get us and how do we use it? So let's say we have an example situation where we have a service that's also an AMI client that will act between an Asterisk server and some clients making requests of some kind. So an operator panel would be a good example of a client server that operates this way. Typically, there's an intermediate process between what you see on the operator panel and what's actually happening on the Asterisk server. So there's something in the middle, filtering events, making sure that nothing bad is being sent one way or the other, and then potentially changing the protocol altogether. So 4 clients in this situation are connected to our AMI handler, that client server is connected to one other server, or multiple servers, doesn't matter. And one of them made a request, which generated a response on the AMI or AJAM socket with the server in question. Now, which client specifically should this response be used for? Ideally, the last request to get the latest response the last request gets the latest response, which is totally synchronous. And this is something we really want to avoid. We've now blocked all new requests from happening until the current request actually responds. So Asterisk dies, the network dies, something else like that happens. We got to wait until a timeout happens in order to continue processing. And this is where using AJAM really comes in. So once we start using AJAM, these events are returned asynchronously, and you'll need something to really tie them together so you know which reply goes to which request. So enter the AMI action ID. This is used to track responses and to specific requests in the stream. So when you make a request, you send the unique action ID tag along with it. I'm going to show that in the next slide. And then you'll look for that unique ID later on in your code. It's very important that your program if your program handles a lot of requests in parallel. Otherwise, you can kind of stick with a synchronous model, but I really advise going away from that model. Being unique is where all the magic is here. It's unique to your program itself, or it's unique for an entire cluster. Typically, just using timestamps of some kind is okay to a degree. It's not exactly the kind of resolution I like. I usually use UUID v1, which kind of have a few examples of that down at the bottom there. And these are always generated every time I make a request. So here's the example. This time around, we're actually using the action ID, throwing it right in the request, and then when we get a response back, doesn't matter where it came from, we actually know how to correlate that to whoever requested it. So this diagram kind of shows us what we get out of that. We can handle lots of requests at the same time. We get a bunch of completely unordered requests from a ton of Asterisk servers out there, and still know how to deal with them. Still know where to proxy do whatever we need to do with them. And we have the action ID set up just for that reason. So request 1, the action ID for request 1, we'll just set it to 1 for example. And then we see that it showed up a little later here. We still know where that goes. It's not a big deal. Everything's taken care of, and I love it. Now, if I send the same request off to a bunch of Asterisk servers, I can actually, I don't need to generate a bunch of new requests new action IDs, depending on the logic of what I'm trying to do. I can actually send that same action ID out to all those servers and then start just handling that as requests come back. It's kind of fun. So thumbs up to Digium. I really like this. It's a very good way of working directly with Asterisk without abusing the command line interface, which is so often done. Also, I guess I'm missing a pinky. I didn't even notice that before. Huh. So quick introduction to Amity. It's an AMI event dispatcher. It's Python and Tornado based. I've already mentioned that before a few times. I love it. It's open source. It works with both AMI and AJAM sockets. And through Tornado, it supports a mixture of asynchronous sockets. So we're talking AMI, AJAM, standard TCP sockets, as well as HTTP server and client, all working in the same program, all very happy together. We can do multiple AJAM sockets as well, which is great. We actually kind of force ourselves into that position once we start using AJAM. We want to dedicate a socket just to requests and responses called the command socket. And then we want to have a socket that's simply waiting for events all the time. And so we're actually maintaining 2 open AJAM connections to every single server that we're dealing with, which is optional. We don't need to have both. And then the wait event socket is actually dispatching how the program deals with broadcasted events. Also, it's not twisted. I don't know if you guys have any Python twisted experience, but it is twisted to say the least. This diagram shows the wait event socket and the command socket kind of working in parallel. So we have 3 Asterisk servers out there and then our AMI handler program sitting in the middle. All I'm really saying here is that we're just maintaining 6 connections for these 3 servers, and it's not going to have a problem doing that. I've seen some systems that have a problem maintaining like 2 sockets at a time, even 1 socket at a time. So there's lots of AMI and AJAM clients out there in the world. In fact, a few of them have debuted at Astricons in the past, as well as on the internet, and become wildly popular. Amity is definitely not unique in what it does. Our goals was just to be simple, by familiarity, mostly, and to handle events asynchronously, because I absolutely love coding that way. Find something that works. It doesn't matter if it's this, it doesn't matter if it's any other AMI solution, and use the heck out of it, or make your own. That's what we do. Why should I, what should I do with an AMI-based solution? What you guys do? You can originate calls, of course, like I said before. Don't call me though. It's perfect for call blasting. Let's say that. Keep a running tally on calls and store them somehow. So this might be important to some call center situations. Execute external programs based on specific call events. I highly recommend 0MQ for dispatching these requests. It has Tornado support as well. You can push information to any HTTP server as sort of an HTTP trigger. So a customer support ticket is opened up as soon as someone calls your customer support line. And we just need to make sure that that information gets pushed somewhere else real quick so that we can have access to it later on. And then send an instant message to whoever picked up the call. So maybe reference a new ticket number, and then this is kind of considered a poor man's screen pop. As soon as someone picks up the call, whoop, there it is. They see it. They can open up that ticket. They can get a little client information right off the bat. No big, heavy interface needed, even though some of them are absolutely amazing. I wish I could use them. Let's get down and dirty real quick. This is the part where, that's actually not horrible to read. Just a quick script. We're going to import a few, this is just using Amity itself. We're going to import a few things that are required for it. Then we're going to set up a client manager. Use my little pointy thing. Ta-da! And then we're going to make a new class based on another class right here, and that class being the Amity client, AJAM client. Then we're going to define a few methods within it, one of which is just do something. That's actually going to help spawn a new command into life. And then the other one is going to handle the core status reply as it comes back into the system. Here, hold on. Well, first off, we're going to add that client to the client manager, and then we're going to specify where I want to connect to. And we can add this server, this server, this server, this server. We can just keep adding servers to that. It's not going to be a big deal. Then we're going to create a quick periodic callback to actually say, hey, I need the core server status. And then, of course, these are going to handle it. So adding an HTTP server into this code, which is not very long at all, I mean, if you can't read this, this is genius, by the way, if you can't read it. We can, maybe 10 extra lines of code, we can have an HTTP server put on top of this as well that, just sits there and says, hey, this is what the most current core status was ever since we received the last event. It's pretty simple to integrate all that together. So handling events once we make a new class based off of the master class, AJM client or AMI client, is pretty easy. You just inherit the client class and add some new methods. So if the method doesn't exist, it's no big deal. We're not even going to worry about it. Nothing happens. So an example, handle dial event, get dial. If you see a dial event come in on the line, do something with it. Chan spy start event, find out if you're being spied on. Conf bridge join event, start publishing information about who's in a conference to your own custom conference notification system. I really encourage you guys to try to do something exciting and use asynchronous code if you guys start using this to really take advantage of it. So use the Tornado Async HTTP client, use the Tornado Async socket handlers. If you have a simple wire protocol somewhere else, no big deal. And of course, you're going to use callbacks or this really cool generator, tornado.gen, to work around blocking socket operations. So here, we're going to make that exciting thing that I was talking about earlier, just making a new ticket in our request tracker server. I'm going to use Tornado HTTP client, and right there, we got a core status coming in on the wire. We're going to check to see if there's a problem. If there is a problem, then we're going to open up our new HTTP client instance, and we're going to do a fetch real quick. Now, right here is where I'm going to say in this current class, I'm going to call new ticket notify, which is right down here, and I'm going to do something with that. So if there was a problem, open up a new ticket and then do something with it. It's actually really simple. I omitted the XMPP code. It's pretty ugly. So instead of using a bunch of callbacks, you can actually use this Tornado or this Python generator that helps handle requests asynchronously, and it's just called tornado.gen. So right off the bat, we just have a few changes. We don't have a callback anymore, and we're just yielding the results to a variable and then doing whatever we want with it later on. And then we wrap all of the original call inside tornado.gen. We say, hey, this is what I want to do, and this is the arguments I want to give it, and let's go to town. So there's a few gotchas that I'd like to share with you guys real quick, just in case you get more in depth, or you might already know some of these. Always timestamp events, especially if you're queuing up a whole bunch of events and your AJM client for some reason completely forgot to reconnect, and now it's getting really old events. So it's best to know when an event happened on a server rather than when you received it. It's also especially important to use when you're using AJM, like I just said. Can't stress that enough. Some Asterisk versions, if not all, have broken HTTP digest auth when dealing with AJM. So it's best to have an HTTPS proxy handling SSL and HTTP basic auth. I don't know if that's still the case. I don't know if we have any Digium developers that work on AJM in here. And then events are not queued until when Asterisk restarts, it's no longer still queuing events for sessions that previously existed. I can understand why they would have done that as well. It's not too big of a deal. You just have to make sure you reconnect as soon as you notice that there's a problem, and then hopefully you didn't miss too many events while that happened. Yeah, we're doing okay. So here's some cool stuff that I've noticed that you can do, I don't know if you guys have played with. Has anybody played with Async AGI? All right, so it's absolutely brilliant. I really appreciate it a lot. When it would require a little bit of hacking to get into Amity. It's not too big of a thing, though. It allows the Asterisk process itself to stop focusing on a specific dial plan route and start focusing on other things. And that's really important when you have a huge call load. So instead of relying on an AGI that takes a little while to respond and potentially causing problems elsewhere, I really recommend using this. Also, use user event AMI application. So what that does is whatever's waiting for events to come in, whatever sockets are waiting for events to come in, you can just generate at any point in the dial plan a user event that says, hey, look at me, or something. And use that to trigger external processes if you're not expecting any sort of response, or if you think you'll be expecting it in 10 seconds, 20 seconds, whatever. Try to be responsible with it. But you really want to use that instead of system or relying on slow AGI. Also, this is kind of a fun concept that kind of came up after looking at some of the security problems that people have mentioned in some of the security-focused presentations. Do-it-yourself registration server. You're an HTTP server. Just do whatever you want with it. This could actually help handle your firewall access to all your Asterisk servers. So register first. So use AMI to see if an extension exists and on what servers, and then if it all works out, go to whatever server it is, secure shell in, add a rule to shore wall, whatever you're using, and boom, you're in. This is very important for me because I actually have mobile phones that I can provision. And so instead of just saying, oh, my boss or someone else that's super high up in the company needs to be able to make sure that they can get in wherever they are in the world, and they go around the world quite a bit. Instead of just keeping the world open, I'm just waiting for that pre-authentication. So does anybody remember POP before SMTP? It'd be more like HTTP before SIP. Here's my wish list. I hope I'm allowed to have one. They said I could have at least one. 0MQ and AMPQ adapters for AMI. That would be super awesome for anybody who's developing message stacks that are going to work with Asterisk in any way. Stored session states so that when Asterisk reboots, we can actually continue to get events queued up for our sessions. And then, of course, JSON. That's just beautiful. Please. So it's kind of into the danger zone time. So you guys have any questions? No questions? One question? What you got? XML. Right, and then I don't know if this has been resolved, but XML's potential was kind of limited in Asterisk 1.6 due to some formatting bugs that didn't quote things properly. So that actually made parsing it in several XML parsers very difficult. I prefer raw. It's like mini JSON. Any other questions? I don't have like chocolate or anything to hand out to people that have questions. So is that what's going on here? All right. So here's a little bit of linkage. The AMI event documentation. Go ahead and give that a read if you haven't already. It's a wonderful asset. The Amity GitHub page, if you're actually interested in using this code, I wouldn't mind 1 or 2 people helping. And then Async AGI info, because I think that's a really important step for people that are developing AGI applications. And then, of course, this little self-plug, Microcom and our subsidiary Liberty Telecom, we consult. So thank you guys very much.